This is Dr.D Govardhan, Professor and Head, Department of Aeronautical Engineering, Ministry of Aeronautical Engineering, Hyderabad. Today's topic is discussing Varignon's theorem and problem related to it. Here the Varignon principle, it is also called law of moments. It can be defined as the algebraic sum of the moments created by the component of forces at a given point is equal to the moments created by its results at the same point. Let O be the reference point, R is the resultant of F1 and F2, which are at a distance of R1 and R2 at a given reference point O dash. According to the Varignon's principle, the moment created by the resultant force at a given point is given by R into R, where R stands for the resultant force, R small r representing the distance between the reference point and the applied force, equal to F1 into R1 plus F2 into R2. Okay, based on this principle, here we are solving one problems now. A uniform beam AB of weight 100 newtons and 6 meters long had two bodies of weights 60 newtons and 80 newtons suspended from its two ends as shown in figure. Find analytically at the magnitude of force and what point beam should be supported so that it may be in a horizontal position. Now, according to the diagram, total length is given, AB length is given 6 meters. At A, one end 60 newtons, in the middle 100 newtons, and at end 80 newtons that forces are acting now. Now, let D be the point at which the force is applying to keep the system in a horizontal position. This force here it is treated as a resultant force. According to the Varignon principle, at a given point, it may be A or it may be B or C or D, the moment created by the resultant force is equal to the algebraic sum of the moments created by its components, that is 60 newtons, 100 newtons and 80 newtons at that point. By using these equations, we can determine the magnitude of resultant force as well as the distance at which it should be supported. Here weight of the rod is given 100 newtons. It is passing through the midpoint. Length of the rod is given 6 meters. Weight of the body supported at A and B are 60 and 80 newtons. Let X be the distance between the point B and the point where the beam should be supported. But the beam is raised horizontal, the moments of it should be equal. Now taking the moments of weights about D and equating the same, 80 into X, this moment we are taking at D. At this moment, the sum of the moments created in clockwise direction should be equal to anti-clockwise direction since the system is in equilibrium position, or the sum of the moments should be equal to 0. Okay, according to these problems now, the forces which are tends to rotate the body in clockwise direction is treated positive, anti-clockwise direction is negative. So 80 is now tends to rotate the body in clockwise directions now positive, and 100 newtons anti-clockwise directions 60 100 60 also anti-clockwise directions negative. Hence, sigma md is equal to, that is the moments created by all the forces at D, it should be equal to 80 into X positive minus 100 into 3 minus x minus of 60 into 3 plus 3 minus x now. It should be equal to 0 required now. By using the relationship, we can determine the values of x. That means where the load should be supported now. So from this relationship, ATX is equal to 60 into 6 minus x plus 100 into 3 minus x. On solving this problem, we got x is equal to 2.75 meters now. And regarding the load, sigma fx is also equal to 0, sigma fy is equal to 0. Since horizontal forces are not at all acting on it, the sum of the vertical forces it is equal to here. 60 is acting downward direction, so negative. 100 is also acting downward direction, negative. Minus also acting downward directions. Total now becomes 240 minus. Hence, in order to keep the body in equilibrium, 240 newtons that should be applied in upward directions. In another problems, a horizontal line PQRS is a 12 meters long, where PQ is equal to QR equal to RS equal to 4 meters. The forces of 1000 newtons, 1500 newtons, 1000 newtons and 500 newtons acted to PQ, R and S respectively with the downward directions. The lines of action of these forces makes an angle of 90 degrees, 60 degrees, 45 degrees and 30 degrees respectively with the PS. Find the magnitude and direction and position of the resultant force. So in this case, first resolve the forces now. At S, this force can be resolved into two components now. Horizontal component is acting toward the left side. Vertical component is again downward directions. Similarly, at R also acting downward directions and toward the left side, and all the forces like this. Now sigma fx is equal to that sum of the component of forces along the x direction. It is equal to the horizontal component of resultant force, which should be equal to, we can take it as 500 cos 30 plus 100,000 sin 45 plus 1500 sin 60. This is give the Rx component. Similarly, Ry component is equal to sigma Fy, which should be equal to 500 sin 30 plus 1000 sin 45 plus 1500 sin 60 plus 1000 into sin 90 now. By using the relations, we got Ry and Rx. So, by using the relations, we got angle also theta is equal to tan inverse of sigma Fy divided by sigma Fx now. So, we can determine the magnitude as well as the direction now. And one more point is required, point of applications. So, by using the relations, we got sigma V, sigma H, the magnitude of resultant force is equal to R is equal to under root of sigma H whole square plus sigma F whole square, which is equal to under root of 1890 whole square plus 3256 whole square. We got 3765 newtons. Theta is equal to, tan theta is equal to sigma V divided by sigma H, which is equal to 1.722. Hence, theta is equal to tan inverse of 1.722 which is equal to 59.8 degrees now. Since both the values of sigma h and sigma v are positive, therefore the resultant lies between 0 to 90 degrees now. The position of the resultant force. Let x be the distance between P and the line of action of the resultant force, then according to the Varignon principle. Here we are taking P the reference point. As in somewhere the resultant force is acting now. It is there. Angle also we are taken now. That is a 59.6 theta degrees. The magnitude also we are taken now. Now according to the distance is not mentioned. Assume the distance is given by x now. According to the Varignon principle, the moments created by the component of forces, that is 1000, 1500, 1000 and 500, at a given point, it should be equal to the moments created by its resultant. So, these horizontal forces are not at all creating any moments at a point P because the distance now becomes 0. Hence, we have to take only vertical components. Okay, according to the x is the distance is given. Hence, 3256 into x is equal to, we have taken all the forces now. That is 1000 into 0 because the distance is 0. 1500 into, that is the cos values we have taken here. Similarly, into 4 distance, 1000 into 0.707 into 8, 500 into 0.5 into 12, which is equal to 1300,852. From this values we got, it is at a distance of 4.25 and so on. Where 3256 is representing the vertical component of the resultant force. So, by using the relations, we can determine the resultant force and its directions and the point of application of the force. These three quantities, magnitude, directions and the point of application, these are treated as characteristics of a force. And one more problem. A system of parallel forces are acting on a rigid bar as shown in figure. Reduce the system to a single force and a couple at a single force and a couple at B now. Now given forces at A is given 32.5 newtons, C 150 newtons, at D 67.5, at B 10 newtons. Then the resultant is given by sum of all the forces now. That is vertical component, resultant of vertical component. Since there is no horizontal component, all forces are now treated vertical only. The vertical component of resultant force is equal to, that is R is equal to, that is sum of the vertical component of all the forces. Here, when the forces are acting upward direction, they are treated as positive, downward directions negative. Hence, according to this problem, 32.5, it is acting upward direction, so positive. 150 newtons, negative, downward directions. Again, 67.5, upward directions, so positive. Minus 10, it should be equal to now, how much? Minus 160. It's nothing but the resultant force is acting in downward directions, so having magnitude is equal to 60 newtons. Let x be the distance of resultant from point A toward the right side. Now, according to the Varignon principle, the sum of the moments created by all the forces which are acting at A, B, C, D is equal to the moments created by the resultant force at that point now. So, let x be the distance where the resultant force is acting. R into x is representing the moments created by the resultant force. It is equal to, because the resultant force is acting downward directions towards the right side, it tends to rotate the body in clockwise directions, hence it is treated as positive. It is equal to minus of 150 into AC, because it tends to rotate again in clockwise directions. 67.5, it is the anti-clockwise direction AD, minus 10 into AB, again it is clockwise directions. That is, here clockwise movements positive and anti-clockwise movements negative. Okay, according to these equations, we got x is equal to 0.833 meters. Now, this single force, this can be represented in a diagram as the resultant force is the force which will show the effect of all the forces which are acting on it. Hence, we remove all the forces which are acting on a body AB and kept only single force R is equal to 60 newtons at a distance of 0.833. This is nothing but resultant force acting at that point A now. Now, single force and a couple at A now. The resultant force R acting at a point E in figure can be replaced by an equal force applied at a point A in the same direction together with the couple now. That is generally here we can take it as the same force in opposite direction to one more force now. These two forces, that is 60 newtons now, what is there now? These two forces are acting in opposite directions and separated by a distance of 0.83, hence a couple executes, which is equal to 60 into 0.833. It tends to rotate the body with respect to the A in clockwise directions, which is equal to 60 into 0.833 is equal to minus of 49.98 now. Similarly, the same force can be shifted at B position also by adding 60 newton and 60 newtons. Now, at B position now, a couple is formed due to the downward force at E and upward force at B. They tends to rotate the body in anti-clockwise directions, which is equal to 60 into 2.667 and is represented here now in this figure now. Okay, this is the way of keeping the resultant force at a various position. Actually, it is acting at E point, but that can be transferred to a point A or B with the same force in the same directions with the addition of couple. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.